Hello everyone, hope you all are doing great. Guys, today in this video we are going to understand topology change in STP, topology change in spanning tree protocol. This is very important topic for network engineer. As you know, STP is heart of switching. Okay, many time interviews asking question from this topic. So this video will cover lots of interview questions, lot of exam questions, right? And lot of concepts are there, right? So if you want to learn everything from the scratch, make sure you will watch this video till the end. Then only you will understand everything. Okay. So first of all, I would like to make you understand that why topology change notification is required in the topology, right? In the network. Okay. So guys, here you can see I have designed one topology in the EVNG, and here in the word file we have some theory part, right? We have some theory. So see why we come up with topology change notification first of all. So if an upstream device is not immediately notified of the topology change in the network, such as link disconnected or port goes down or port come up, whatever change will occur in the topology, if switches will not generate a notification, right, like topology change notification, then what problem can happen? The upstream device may send packets to an unreachable link when the topology changes. How? Let me make you understand that first. See here in this topology, now are you able to see MAC address of this switch? Are you able to see MAC address of this switch? Are you able to see MAC address of this switch? Right? As you know, this switch has lowest MAC address, so this switch will have lowest bridge ID. So this switch will become what? Root bridge. Am I right? This switch will become root bridge RB. So all ports of root bridge will become DP. This port will become RP. This port will also become RP. Here you can see MAC address is lower than this switch, right? Switch 2 have lower MAC address than switch 3, so this port will become again DP and this port will become alternate. Fine. So this is very basic things. Okay, just suppose MAC address of this computer is A and MAC address of this computer is B. Don't consider this MAC address, okay, for a moment. Suppose MAC address of computer A is A and MAC address of computer 2 is B. Okay, computer A one MAC address is A, computer 2 MAC address is B. So this switch will learn a MAC address on this port on 0/2. As you know, switch maintains CAM table. So in the CAM table of switch 2, there will be entry that on 0/2 this switch learn one MAC address A. And this MAC address, B MAC address, this switch will learn on which interface? On this interface, on 0/0. So on 0/0 there will be one MAC address that is nothing but B. This is CAM table of switch 2. What will be the CAM table? What will be the information in CAM table of switch 1? Here on 0/0 interface, switch will learn this MAC address. On 0/0 it will learn A MAC address, and on 0/1 it will learn B MAC address. Okay. In the same way, if I will talk about the CAM table of switch 3, here on 0/0 it will learn A MAC address, and on 0/2 it will learn B MAC address, right? And by default, MAC aging time of switches is 300 seconds. 300 second. Fine. So suppose if this link will goes down, okay, if this link will goes down or any link will goes down, suppose here I have removed this PC, okay, so in the MAC address table of switch 1 there is one entry for MAC address A, and this entry will be there for 300 seconds. That means if this link is down or maybe this port is down, but still for 300 seconds switch will forward traffic towards switch number 2 whenever switch 1 will receive traffic where destination is A. Suppose this switch is receiving a traffic, this port is down, suppose this is down port, and this switch is receiving a frame where destination MAC is A. So in the MAC address table you can see destination MAC address A is learned on which port? On 0/1. So it will forward from this interface. When switch 2 will receive, switch 2 will remove it, discard it, right, because this port is down now. So if there is no notification, that means upstream switch will forward the actual frame on the wrong link, on the link which is not available to reach the destination. Yes or no? So this is why we come up with topology change notification. So you will understand what how topology change notification can help in the topology, so that upstream switch will not send traffic on the bad link. Fine. Means if this port will goes down, and if this switch will inform to root bridge that there is some change in topology, then it is responsibility of root bridge now to inform all other switches, right, to this switch and this switch. Every switch root bridge will tell to every switch, please set your MAC caching time 15 second from 300 second, right? So whenever change will occur, root bridge will tell to all other switches, all other non-root bridge switch, that change your MAC caching time from 300 second to 15 second. Okay, so we are going to understand one by one how many types of topology change are there, and how this topology change will works. Okay, so as you can see over here, we have three types of topology change. Number one is insignificant topology change. Guys, insignificant topology change means what? See, in the diagram, I am running STP here. Here I am running STP, yes or no? This port is my access port. This port is not connected with any another switch, right? So STP is running between these switches, right? But if this port will goes down or this port will come up, that means change is occurring. Actually, STP will treat this change as a change in spanning tree protocol, change in STP topology. But this is outside interface from the STP domain. So that's why we are saying this type of change is nothing but insignificant topology change, right? Directly topology is not changing, directly STP topology is not changing, right? Access port is coming up or going down. So that type of change is known as insignificant change. So here you can see first is insignificant change, and insignificant change means whenever access port will goes down or come up, that type of change is known as insignificant change. After that, indirect topology change. Guys, indirect topology change means, indirect topology change means what? Whenever RP port of a non-root bridge switch will goes down and alternate port is available there, that type of change is known as indirect topology change. See, in the topology, this is DP, this is also DP, this is RP, and this is alternate. This is RP, this is DP. Yes or no? So if RP port of the switch where alternate port is available will goes down, that type of change is known as indirect topology change. And direct topology change means whenever RP port will goes down but alternate port on that switch is not available, like you can see on switch number 2, RP port is available but there is no alternate port. So if this RP port will goes down, this is direct topology change. If this RP port will goes down, because here alternate port is available, this is nothing but indirect topology change. Okay, now let me make you understand one by one very quickly. Okay, and first of all, I am going to make you understand insignificant change. I will show you practically as well. Okay, so see, insignificant topology change, when the access port of the switch goes down and come up, the switch treat it as topology change in the network and it generate TCN BPDU. TCN BPDU, TCN stands for topology change notification to inform the root bridge, and this type of change is nothing but insignificant topology change. So see, in this topology, suppose this access port will goes down. If this access port will goes down, what this switch will do? This switch will send one TCN BPDU to root bridge, right? This is how root bridge can understand that since some changes occur in the topology, right? Who will inform to root bridge? Non-root bridge switch. With the help of which type of BPDU? With the help of TCN BPDU. There are only two types of BPDU in the STP, right? First one is configuration BPDU and second one is TCN BPDU. Configuration BPDU will be generated by root bridge only, and TCN BPDU will be generated by non-root bridge switch only. Okay, so non-root bridge switch will generate what? One TCN BPDU, right, to inform root bridge. Now what root bridge switch will do? Root bridge will not generate TCN BPDU, root bridge will change some bits in the configuration BPDU, right? As you know, root bridge switch is sending configuration BPDU after every 2 seconds. So now whenever root bridge will receive a TCN BPDU from non-root bridge switch, after that in the configuration BPDU, root bridge switch will on TC bit. TC means topology change bit. As you know, in the configuration BPDU there are one flag field. In the flag there are two bits, one is TC bit and another one is TC ACK bit. Okay, so first in the first configuration BPDU, root bridge will on both bit. It will set yes, it will set yes. By default in the configuration BPDU it was set no. It was set no over here. I am going to show you practically as well. I will capture this link. Okay, so whenever root bridge will receive a TCN BPDU, after that what root bridge will do, in the first configuration BPDU it will on TC bit and TC ACK bit, so that this switch number 2 will came to know that root bridge now understand that changes occur. Okay, if this switch will not receive acknowledgement from root bridge switch, until and unless this switch will not receive acknowledgement, it will send TCN BPDU again and again to root bridge, right? So that's why root bridge have to inform to this switch that I have received your TCN BPDU, yes or no. So it will send configuration BPDU. In the configuration BPDU it will on both bits, right? In the second configuration BPDU again it will off TC ACK bit. There will be TC bit on only, right? And for the forward delay time and max edge time, right? As you know, max edge time is 20 seconds and forward delay time is 15 seconds. So total will be 35 seconds. So for 35 seconds, root bridge switch will send the configuration BPDU with TC bit on. Okay, let me show you practically. That will make you more clear. And I know now you are getting some confusion. Here I am going to show you first of all that okay, see here on this switch, if I will run a spanning tree protocol, so a spanning tree protocol, see 0/0 is my root bridge now, right? 0/0 which is connected to switch 1, right? 0/1 is my designated port which is connected to switch 3, and 0/2 is designated which is connected with PC number 1. Yes or no? Okay, and if you will check MAC address table, so MAC address table, now here you can see some entries are there, but these are the MAC address of switches. So what I am going to do, I am going to ping from PC1 to PC2, right? So all the traffic will be flow via root bridge switch, yes or no? All the traffic, this switch will learn this MAC address on this port, this switch will learn this MAC address on this port, right? In the same way, this switch will learn this MAC address on this port, this MAC address on this port, right? And switch 1 will learn this MAC address on this port and this MAC address on this port, yes or no? Now first of all I am going to capture this link. Now only root bridge switch is sending what? Configuration BPDU, where TC bit and TC ACK bit is off. Let me show you that first. Here I am going to capture the link Ethernet 0/1. Capture, and which link? 0/0 interface. I am going to capture it. Okay, so see a spanning tree. These are configuration BPDU. Here you are able to see the configuration BPDU. Who is sending? Root bridge switch is sending. Okay, let me open this configuration BPDU. Let me maximize it. Fine. Okay, here in the Ethernet header also you can check the MAC address. Sender MAC address is this one. This one is the MAC address of switch 1. Okay, in EVNG here you can see in the last octet, last field 00, in the second last field 10, right? This one is MAC address of switch 1. In the topology also you can verify if you want to verify. Okay, where is topology? Let me show you. Here you can see this is MAC address of switch 1. Now, okay, now I am going to open one configuration BPDU, and here you can see this is STP message, right? Let me open it. Here you are able to see one flag field. Yes or no? Where is flag field? Okay, this one, right? There is information of hello timer, forward delay timer, maxes time, right? Everything, version, protocol, BPDU type. So this is configuration BPDU. You can see I am interested to show you this flag field over here. Let me open this flag field in detail, and here you can see there are only 2 bits. One is topology change acknowledgement and it's saying no, and another one is topology change bit, it is also off. Now what I am going to do, now I am going to down this interface. Which interface? This interface, this access port. So what this switch will do, this switch will generate one TCN BPDU, right? And I will show you that TCN BPDU first. So I think I have access of switch 2 or not. Yes, I have access of this switch. Let me take access of all switches. Let me configure host name over here as well. Host name switch 2. Let me take access of switch 1. Enable config t and host name, let's say switch 1. Fine. And now I am going to take access of switch 3. Enable config t and host name switch 3. Fine. Now first of all, here you can see only root bridge is sending what? Configuration BPDU. There is no any other BPDU in the capturing, right? Now I am going to down the access port of switch 2. Access port means I am going to down this port 0/2 port. Okay, so go to interface E 0/2 and say shutdown. Okay, see now. Okay, now are you able to see the topology change notification here? Who is sending this BPDU? Switch number 2. Let me stop the capturing. Okay, and now here you can see, okay, now I cannot stop because I need to show you the TC bit as well. Okay, so first of all, if you will open this topology change notification message, here you can see in the TCN BPDU there will be only 3 information, nothing is there, right? Protocol, version and BPDU type. There is only 3 information. So when root bridge switch will receive this TCN BPDU, what root bridge will do? In the next configuration BPDU, root bridge will on TC bit. Here you can see this is the configuration BPDU. Who is sending? Root bridge, because non-root bridge cannot send configuration BPDU. And here now in the flag field you can see acknowledgement is yes, and topology change is also yes. Yes or no, right? So root bridge is telling to switch number 2 that I have received your TCN BPDU, right? With the help of acknowledgement field, acknowledgement bits, switch 1 is telling to switch 2 that I have received your TCN BPDU. After that, root bridge switch is sending configuration BPDU with TC bit on. So when whenever non-root bridge switch will receive TC bit on BPDU, it will set their MAC aging time 15 seconds from 300 seconds. Yes or no? So okay, and in the next BPDU, let me show you the next BPDU. Okay, this BPDU. In this BPDU, in the second BPDU, root bridge will off acknowledgement field. Yes or no? See here. Now it's saying acknowledgement no, but TC bit is still yes. So for 35 seconds it will send TC bit on BPDU. Yes or no? Guys, what is the benefit? Now let's understand the benefit. If there will be no TCN BPDU, right? If there will be no any TCN BPDU, and if this port will goes down, suppose MAC address of this machine is A, MAC address of this machine is B. So this switch learn this MAC address on which port? On this port. right? And it will store that information for 300 seconds. That means for 300 seconds this switch will forward frame whenever frame will come to switch 1 where destination will be A towards switch 2, it will send towards switch 2. yes or no? जब भी इसके पास कोई फ्रेम आएगा जिसके अंदर में डेस्टिनेशन क्या होगी ए, वो किसको भेजता रहेगा? स्विच 2 को। 300 सेकंड तक के लिए कम्युनिकेशन नहीं होगी। दिस इज द प्रॉब्लम. So that's why we come up with topology change notification message, that is TCN BPDU. Okay, now let me run no set command again over here, and again if I will run no set command on switch 2, it will send what? TCN BPDU. It will send one TCN BPDU again. Yes or no? Let me show you. Go to switch 1 and now I am going to say no set over here. Let's say no set. Okay, so see, it will send one more TC bit. Where is that? TCN BPDU. This is the switch. Let me run shutdown. Okay, so here you are able to see the topology change notification message. Yes or no? And if I will run no set command over here, then again switch will send one TC bit. Whenever port will goes down or port will come up, every time switches will, non-root bridge switches will send what? TCN BPDU. Okay, so just wait. Now root bridge is sending TC bit on BPDU. The reason why switches is sending TC bit on BPDU, so that non-root bridge switch will set their MAC aging time 15 seconds from 300 seconds, right? Okay, now let me run no set command. For no set command, it's not sending, I think, TCN BPDU. So this is actually a problem of simulation software, but in real time whenever port will go down or port will come up, in the both case it will send TCN BPDU. Okay, now let me configure one IP address over here on the PC1. Say no, and let me verify MAC address of this interface as well. Interface, how I can check MAC address of PC? So interface F0/0 and you can say include by. So see, MAC address is this one. Okay, so I need to change it here. Let me paste this MAC address. Fine. Here also, first of all, let me configure IP on PC1. Config T, interface F0/0, say no set, and IP address 10.0.0.1. Let's say 10.0.0.1 is IP address of PC1 and this is MAC address of PC1. Let me do same thing on PC2 as well. Enable a show interface F0/0 include by. See, this is the MAC address of this interface. Let me copy it and let me paste it over here. Okay, now I am going to configure IP on PC number 2. So config T, interface F0/0 and say no set, IP address is 10.0.0.2, 255.0.0.0. Fine. Now if I will ping from PC1 to PC2, it will work, right? Ping will work. Let me ping 10.0.0.2. It's not working. I think this port is down. No, it's working. Yes or no? See, it's working. Let me repeat. Let's say 10,000, 1,000 or 10,000 packet. I am sending 10,000 packet from switch 1 to switch 2. Now in the MAC address table of any switch. Let me show you the MAC address table of switch 1 here. So MAC address table. Okay, so see guys, this entry, MAC address of the PC1 is F4, this one. This MAC address is learned on which interface? On 0/0 interface. And MAC address of PC2 is C3000. So this MAC address on which interface? Switch have learned this MAC address on 0/1. And this entry will be there for how much time? For 300 seconds. You can check. So MAC address table aging time, right? By default MAC aging time is 300 seconds. Okay, now I am pinging from router 1 from PC1. Yes or no? I am sending ICMP traffic. Now I am going to down the router switch 2 interface. Where is switch 2? Here. Let me say shutdown. Okay, so see, now ICMP traffic is dropping, but still in the MAC address table of switch 1 you can see MAC address table entries are there, right? This MAC address is learned on which interface? On 0/1. But if this switch will send any traffic for this MAC address from 0/1 interface, communication will not happen, right? Because this interface is not down, this user is not available. Yes or no? So it will update their MAC address table after 15 seconds, because switch 2 will send one TCNP PDU. Otherwise it will update their MAC address table after how much time? After 300 seconds. Okay, now still there is some problem. Now this switch don't have entry, right, for this MAC address, right? And if this port will come up, switch will do what? Unknown unicast flooding, because switch don't have entry for the MAC address of this PC2 MAC address, right? C300000, right? This MAC address is not showing in the MAC address table of this switch. So until and unless this switch will not receive frame from the PC2, it will not learn the MAC address of PC2. Yes or no? And first time all switches will perform what? Unknown unicast flooding. On switch number 3 also you can check. Go to switch number 3, and here also if you will run so MAC address table, so MAC address table, you can see this MAC address. This MAC address is available over here on which port? On 0/2 port, right? Because this machine is sending keep alive message, that's why there is one entry. But if we are not running any protocol between this between switch 3 and PC, that means first time whenever this machine, any switches will receive any frame for the MAC address of PC2 or MAC address of PC1, switch needs to perform unknown unicast flooding. Okay, for now also, suppose if I will ping from PC2 to PC1, if I will ping what? Ping 10.0.0.2 from here. So source will be this MAC address, destination will be this MAC address, but in the MAC address table of switch 3 there is no any entry for the destination MAC address. Yes or no? So switch will do what? Switch will definitely perform unknown unicast flooding. So every time whenever user will goes down or user will come up, switch will perform unknown unicast flooding. It can increase the CPU utilization of switches, and whenever CPU utilization of switches will increase, performance will automatically decrease. Yes or no? So this is problem, still problem. First one problem is resolved, that is MAC aging time. By default MAC aging time was 300 seconds. So with the help of TCNP PDU we have reduced it, right? We have set it for 15 seconds, right? Only for 35 seconds, right? After that again it will send when non-root bridge switch will receive the normal configuration BPDU from root bridge, again it will set their MAC aging time 300 seconds. Got it? Now let me run no shut command over here, right? So every switch will perform unknown unicast flooding, and now you can again see PCs will be able to ping, but after how much time? After 30 seconds, right? That means whenever you will connect a computer on access port, that user need to wait for 30 seconds, because this port will take 30 seconds to come in forwarding state from the blocking state. Yes or no? It will take 30 seconds. And now if you will check it, I think switch to, yeah, PC1 is sending and receiving ICMP request. Now it is for in forwarding state. Where is switch to? Here it is. Let me maximize it, and here you need to understand some basic concept. Okay, now I am downing this interface. I am running shutdown command again over here. Okay, so see, PC is not able to ping, right? Now if you will check, so a spanning tree, see 0/2, 0/2 is not showing over here. Let me run no shut command over here, interface E0/2, say no shut, and so a spanning tree, see 0/2 is in which state? In listening state. After 15 seconds it will come in learning state, right? And then it will come in, now you can see again still it is in listening state. So now it is in learning state. It will spend 15 seconds over here. We had discussed in STP state this thing. Okay, still it is in learning state. So this port need 30 seconds to come in forwarding state, and after 30 seconds user can send traffic. Now you can see port is in forwarding state. Now PC1 is getting reply, yes or no. But still problem is a non-unicast flooding, and PC need to wait for 30 seconds. Switch port will take 30 seconds to come in forwarding state. So what is the solution? So solution is here. Okay, so now guys, here I have written some step as well. So if PC1 on switch 2 gets shut down, the switch detects it as a topology change and generate TCN BPDU from the root port E0/0 toward the root bridge. Okay, in step 2, root bridge will send TCN ACK back to the switch 2, and it also send configuration BPDU with TC bit on to all the downstream switch to inform about the topology change in the network. Yes or no? Step 3, switch which receive configuration BPDU with TC bit change their MAC aging time from 300 seconds to 15 seconds. Drawback: if there is no communication between PC1 and PC2 for 15 seconds, switch will remove the MAC of PC2 as well as all the switches will remove. If there will be no any frame exchange between PC1 and PC2, all switches will remove the entry from their MAC address table. Then switch will perform a non-unicast flooding. A non-unicast flooding take place. So note, when the access port come up from the blocking state, it will take 30 seconds. This is also a problem, right? To come in forwarding state, that means STP needs 30 seconds to converge their topology. Every time whenever you will connect switch a machine to a switch, it will take 30 seconds to come in forwarding state. So this is problem. So what is the solution? Solution is here. Solution is port fast. Enable port fast on the access port of switch, which makes a port move from blocking state to forwarding state immediately without delay, right? So if you will configure, if you will enable this feature, port fast feature on the access port, then that port come in forwarding state immediately from the blocking state. It will escape listening state and learning state. Okay, and one more thing, it will not generate any TCN BPDU as well. So there will be no topology change and there will be no MAC aging. So actually machines will not, you know, rebuild the MAC address table after 15 seconds, because this is the problem still. If switch will not send the TCN BPDU, that means there is problem. Switch will not update their MAC address table, right, till 300 seconds. So for 300 seconds switch will send traffic on wrong link, maybe on wrong link, yes or no? Yeah. So, and will not generate TCN BPDU, so that there will be no change in the MAC aging time. Now how to enable port fast? Go to interface and say switch port mode access. First of all, you have to configure a mode static access. By default it is dynamic access, right? So first of all you have to configure it as access port, and then you can run this command, spanning tree port fast. Let me show you Here is the capturing. Let me take capturing on the front as well. Okay, now let me take access of switch 2. Here is switch 2. So if now if I am running shutdown command on ethernet 0/2, say shutdown, it is sending TCNBP to you, right? Say no shutdown. Okay, so what I am going to do now, I am going to configure this port as access port first of all. And if you want to check that this interface is configured as access or not, so interface F0/2 and say switch port by running this command. So interface E0/2 and say switch port. Okay, by running this command, here you can see this port is configured as dynamic auto. So here I am going to configure static access. Go to global config mode, after that interface ethernet 0/2 and say switch port mode access. Okay, and if you will verify now, so now you can see this port is configured as static access, and here now on ethernet 0/2 you can run command spanning tree port fast. Okay, are you getting one message over here? A spanning tree port fast. This command, you need to run this command port fast. Here you can see the warning, port fast should only be enabled on the port connected to a single host, right? If you will configure port fast on the trunk link guys, okay, just wait, you will automatically understand those things. Make sure for now, if you are enabling port fast on the port, so that port should be connected to a single host only, right? That port is not connected to hub, or that port is not connected with switch. Okay, connected to hub, right, and switch, breeze, these things, etc. This interface, when port fast is enabled, can cause temporary breathing loop. Okay, so if you will configure port fast on the port which is connected with hub or switches, then loop can form. Yes or no? Because port fast means, if you are enabling port fast on a interface, that means you are disabling a spanning tree protocol. So now if I will down this interface, it will send TCNBPDU or not? Say shutdown. See, it is not sending any TCNBPDU now. Yes or no? Here is capturing, you can see. Fine. So this is all about the insignificant change. Let me discuss the second type of change, that is indirect topology change. Okay, hope it is clear to you. Insignificant topology change. Fine. So problem, I have discussed problem, also I have discussed solution as well. Okay, now direct topology change. Direct topology change means whenever RP port of a switch will goes down and alternate port is available there. Oh my god, I think I have said that whenever RP port will goes down and alternate is available, that is indirect topology change. No, that is direct topology change now. That is actually direct RP port is going down and alternate port is available. That type of change is direct topology change. Indirect topology change means RP port is going down but alternate port is not available. Okay, so let me make you understand this first. So here in this topology, as you can see, if this port will goes down, this link or this port will goes down, so this is RP and alternate port is available on this switch, so this type of change is nothing but direct topology change. And what will happen in direct topology change? See here guys, I have written step by step. Step 1, if the link between switch 1 and switch 3 goes down, both the switch will remove the MAC address learned on the connected port. So what I am saying, suppose MAC address of this switch is again B and MAC address of this switch is again A. Don't consider this MAC address for now, right? This switch will learn B MAC address on this port and A MAC address on this port. Yes or no? Switch 1 will learn B MAC address on this port and A MAC address on this port. Whenever this link will goes down, first thing that switch will do, switch 3 will remove this entry right from their table, because this port is down now. If port will goes down, then immediately switches will remove the MAC address which learn on that interface, all the MAC address which switch have learned on that interface. Okay, after that this switch will also remove this MAC address from their MAC address table. Yes or no? This is the first step will happen when this link will goes down. Okay, now second thing, step number 2, switch 3 remove superior BPDU received from, see, if this link will goes down, this link will goes down till, if this link is up, that means this switch is receiving superior BPDU over here. That's why this port is what? RP. But if this link will goes down, it will not receive superior BPDU over here, right? It will not receive BPDU, and you know maximum time is 20 seconds. So this switch is going to hold the BPDU, previous BPDU, for 20 seconds only. And this is alternate port, so alternate port can receive a BPDU. Yes or no? So this switch 3 is receiving a BPDU over here, and now switch 3 is not receiving superior BPDU over here. So this BPDU will become what? Superior. This BPDU will become what? Superior. Okay, but after 20 seconds it will install this BPDU in their database. Yes or no? Because for 20 seconds it will hold the information which received from switch 1 on this interface, right? So after 20 seconds this port will become what? Okay, you can consider like this if you are not understanding. See, this switch is sending superior BPDU over here. If this link will goes down, this switch will not receive superior BPDU on this port, and it is receiving a BPDU over here. So this BPDU will become what? Superior. Yes or no? This BPDU will become superior. So now this switch is receiving superior BPDU on this port. So this port will become what? RP, and it will take how much time to move in forwarding state from blocking state? 30 seconds. So still here convergence time is 30 seconds. So whenever direct topology change will occur, STP topology will take 30 seconds to converge the topology. Fine. This is direct topology change. In direct topology change, what will happen? Block alternate port will become what? RP. Yes or no? Okay. So here also you can read these things in step 3. Root bridge generates the configuration BPDU with TC bit on. Okay. Now what will happen? Next thing, when this link will goes down, it will stop receiving superior BPDU over here. It will receive superior BPDU over here. This port will become RP. After that, this switch will generate what? One TCN BPDU to inform root bridge. That because this switch don't know that root bridge have knowledge that link between my RP port goes down, right? So it will generate one TCN BPDU, and TCN BPDU will be forwarded from RP port. TCN BPDU can be forwarded by RP port only. Okay, so it will send one TCN BPDU to root bridge, and then root bridge will on TC ACK bit and TC bit, right? In the first packet it will on both bit. In second BPDU it will on only TC bit. Okay, so these switches will set their MAC aging time again to 15 seconds. Yes or no? After 15 seconds, if there will be no any communication between PC1 and PC2, the MAC address table will be erased, and switches will perform what? A non-unicast flooding. Yes or no? Okay, so still some problem is there in the direct topology change. Yes or no? So root bridge will generate a configuration BPDU with TC bit on, and continuously MAC aging time change from 300 seconds to 15 seconds. Yes or no? Step 4. If within 15 seconds PC1 ping to PC2, it will drop. Definitely for 15 seconds it will not work, because for 15 seconds this port is down, and this port is not in forwarding state. So there is no any connection between PC1 and PC2. Yes or no? The new connection is going to become this link, right? Earlier the connection was this one. Okay, so for 15 seconds it will not work. After 15 seconds switches will perform a non-unicast flooding, and then again switch will rebuild the MAC address table. Okay, so convergence time in the direct topology change is still 30 seconds. So what is the solution? Solution is enable uplink fast. Guys, uplink fast is also a feature of STP. What uplink fast will do? See, enable uplink fast on a switch which has an alternate port, because alternate port will become what? RP. And we need to move alternate port quickly from blocking to forwarding. So we will enable this feature on only those switches where alternate port is available, right? Not on switch 2, not on switch 1, right? We need to enable this feature only on switch number 3. So enable port fast on switch which has an alternate port. Yes or no? If the RP port goes down, the alternate port will become RP and come forwarding immediately without delay time. If PC1 ping to PC2 within 15 seconds, switch to forward to switch 1 packet definitely towards the root bridge, but there is no any connection between root bridge and switch number 3 now. But in the MAC address table of switch 1, now it has entry, right? In the MAC address table of this switch 3. This MAC address is learned on this interface, so it will forward to this switch, but it will drop, root bridge switch will drop for 15 seconds, right? After that the alternate port will come in forwarding state immediately without any delay, right? Switch 2 will forward to switch 1 and packets get dropped as the MAC B of PC2 is learned on Ethernet 0/0 of switch 2. Exactly, yes or no? But after 15 second unknown unicast flooding take place as MAC address get removed from the switch 2 CAM table, right? That means every time whenever change will occur, this is the benefit of topology change notification. Then switch is going to rebuild their MAC address table after 15 seconds, right? Otherwise switches need to wait for 300 seconds. Okay, now solution is to avoid these, right? We need 30 seconds. User need to wait for 30 seconds to communicate. So to avoid this, uplink fast not only move the new RP port forward immediately, but also send a dummy frame on Ethernet 0/1. Ethernet 0/1 of switch 3 is connected to switch 2. This is 0/1. Okay, so it will send dummy frame from here, so this switch can learn the MAC address of this switch on this port. Yes or no? Okay, after that, for each MAC learn on switch 3, it send a dummy frame. So suppose in the MAC address table of switch 3, this is switch 3, and here is suppose this PC MAC address is B, this is switch 2. Okay, so in the MAC address table of this switch, if there is information of B MAC address, so it will send a dummy frame, and with the help of dummy frame it will send all the MAC address. So this switch can learn all the MAC address if you will configure what? Uplink fast. Okay, so make sure in the topology, if you have a switch where one port is alternate and one port is RP, on that switch you will enable uplink fast. There is two advantages. First, it will reduce the convergence time, and second advantage, it will send all learn MAC address to switch number 2. Okay, so if switch 2 will receive all MAC address from switch 1, switch 2 will not perform unknown unicast flooding. So here we can stop unknown unicast flooding as well. Yes or no? Hope you are getting my point. If guys you are not getting my point, let me know in comment. If you have any doubt, let me know in comment. Definitely I will make another video. Okay, I can make video in Hindi as well, but lots of my subscribers don't understand Hindi. That's why I'm making video in English. But my English is also not good, and English is not my native language. Okay, so how to enable uplink fast? To enable uplink fast, you can run command spanning tree uplink. So let me take you on the switch number 3, and here I am going to enable uplink fast. Okay, say a spanning tree uplink fast, this command. Okay, So this is solution of direct topology change. Now last type of topology change is indirect topology change. So guys, in direct topology change, what will happen? What I said that whenever RP port of a switch will goes down and alternate port is not available, that type of change is indirect topology change. So suppose when this port will goes down or this port will goes down, it will stop receiving superior BPDU over here, yes or no? Now it is receiving superior BPDU on this port, so that's why this port is RP. Now RP is down, yes or no? And here this switch is not receiving any BPDU, it is only sending BPDU because this port is DP, yes or no? So this switch is not receiving any BPDU. Now if RP port will goes down, that means what this switch will do, this switch will think that I am not receiving any BPDU, that means I am what? I am root bridge. I am root bridge. And it will start sending their superior BPDU. It will send their superior BPDU from this port, from their DP port, right? When switch 3 will receive, that switch 2 is telling that I am root bridge. I have superior BPDU. It will compare, switch 3 will compare the BPDU which switch 3 is receiving over here and the BPDU which switch 2 is sending, right? And then switch 3 will came to know that no, switch 2 is not superior BPDU. So what this switch will do? So this switch will send one BPDU from here, right? Which BPDU? This BPDU of switch 2. And when switch 2 will receive BPDU on this port, right? And that BPDU will be what? Superior. This port will become what? RP, right? From the DP. First it will go in blocking state and again it will come in forwarding state. So I have written these things also step by step. Here you can read. Indirect topology change, right? When RP port of a switch gets down and no alternate ports available on the switch, such type of change is known as indirect topology change. Step 1, when link between switch 1 and switch 2 will goes down, right? Switch 2 will remove the superior BPDU received on Ethernet 0/0 and when the switch does not receive BPDU, it will assume itself as a root bridge and generate BPDU from E0/1 from this interface, right? Step 2, when switch 3 receive BPDU from switch 2, it will ignore because it is not superior. As switch 3 has superior BPDU received on Ethernet 0/0 and inferior BPDU at 0/1, expiring the inferior BPDU after 20 seconds, and switch 3 informs switch 2 that switch 1 is root bridge, yes or no? So switch 2 makes it Ethernet 0/1 port as RP and switch 3 make its Ethernet 0/2 port as DP, because now this port is transmitting BPDU and this port is receiving BPDU. So port which receives superior BPDU, that port is nothing but RP, and the port which transmits superior BPDU, that port is nothing but DP. Okay, so this is all about the indirect topology change, how topology will converge in indirect topology change. So here what will be the total convergence time, guys? So let me show you the total convergence time. First of all, when this link will goes down, right, what will happen? If this link will goes down, first of all it will send their superior BPDU, it will send their on BPDU that I am root bridge, right? And this switch will store this BPDU for 20 seconds because max says time is 20 seconds. After 20 seconds, this switch will expire this BPDU, yes or no? So here it will take how much time? 20 seconds, right? After 20 seconds, it will send what? Superior BPDU, right, which is receiving with root bridge. So again this port will take how much time? 30 seconds to come in forwarding state. So total time taken in the indirect topology change will be 50 seconds, right? So 50 seconds is required to reconvert the topology whenever indirect topology change will occur in the network, yes or no? Yes, whenever indirect topology change will occur, STP needs 15 seconds to reconvert the topology. Okay, so what is the solution? That means for 15 seconds user cannot communicate, right? So solution is backbone fast. Backbone fast should be enabled on the every switch, right? It reduced 20 seconds of MAC aging timer if any indirect topology change occur in the network. Okay, so if you will enable backbone feature on switches, what switches will do? Whenever indirect topology change will occur, it will reduce the MAC aging time. Okay, sorry, max is time, not max is in time. Max is time, yes or no? Put all the change their state from blocking to forwarding state in 30 seconds without running the max aging time. It will not take 50 seconds for the convergence. And how to enable? This is the command to enable. Okay, a spanning tree, backbone. Okay, so guys, for now what I am going to do, let me ping, let me send one 10,000 ICMP packet again from here, enable and ping 10.0.0.2. first of all let me check I'm able to ping or not. I'm not able to ping. Let me go here and so a spanning tree. So this port is root port, this port is designated port, and 0/2 is down. So let me up interface E0/2, say no set over here, right? It will not take 30 seconds. Why? Because I have already enabled what? Port fast on this access port. So that's why you can see I'm able to ping, right? Let me send 1000 packet, repeat, set, let me say 1000, and now I am going to shut down this interface. Which interface? This interface. Okay, so first of all here I am going to down RP of switch 2, say shutdown, right? Before running shutdown, let me hit enter here, right? Traffic is sending, let me shut down. Now see how much time it will take. 3, 4, 4 packet is dropped, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. See, it will take much time, right? 50 seconds. For 50 seconds there will be no any communication. After 50 seconds you can see now packet is moving. Now topology have converge. Okay, yes or no? And let me run no set command over here again, no set. See, again it will take much time to come in forwarding a state, because again this is indirect topology change. Yes or no? Now what I am going to do, now I am going to enable this beautiful feature over here, backbone fast. Okay, so just wait. Okay, now everything is working fine. Now I am going to enable a spanning tree, and what is the command? Command is a spanning tree backbone fast. Okay, on switch number 1 also enable config tree, a spanning tree backbone fast. On switch number 3 also I am going to enable backbone fast, a spanning tree backbone fast. Okay, let me minimize this. Okay, now I am again going to send 1000 ICMP packet from here. See, and let me down which interface? Ethernet 0/0, say shut down. See how much time it will take. 2, 3, 4, 5, 6 7. I have done which interface Ethernet 0/0 op switch to yes. I think backbone fast is not working. Backbone fast, yes, backbone fast is working. You know, see here how much packet is dropped. 1 2 3 4 5 6 7 8 9 10 11. I think almost same, right? No, some changes are there, but still it's taking time, right? So this is problem of really simulation software, right? On real devices it will not take this amount of time to convert topology if you will enable backbone fast service on all switches, right? I think I have enabled backbone services on all switches, but still it's taking much time. But no problem, guys, it should not take much time. Let me do one more thing over here. Let me send again 1000 ICMP traffic. Let me take you on switch 2, and here this time I am going to run no short command on Ethernet 0/0. Let me send and say no set over here. Let me check how much packet it will drop. So a spanning tree, so 0/0 is in listening state, right? It is not escaping. Listening. A spanning tree for VLAN 1 and not for VLAN 1, backbone fast clear. Okay, no problem. Maybe this is because of simulation software. But guys, this is all about the topology change in a spanning tree protocol. We have discussed three types of topology change, right? Insignificant, direct, and indirect. Hope you like this video. If you have learned something from this video, please hit on like button. If you have any doubt, please let me know in comment. Definitely I will make another video on it. Okay, guys, and if you haven't subscribed this channel, please subscribe this channel as well, because I am uploading this type of videos. So if you are a network engineer, or if you are planning to become a network engineer, this channel can help you to grow your professional life. Okay guys, bye bye, thanks for watching.